In trigonometry, we have two very special right triangles. One of them is called the 30, 60, 90 triangle, and that is because the two acute angles are 30 and 60 degrees, and then of course the 90 degree is what makes our triangle a right triangle. So this is called the 30, 60, 90 right triangle. And what's special about it is that it has very special relationship with the sides. So no matter how big or how small the triangle, when you have 30 degrees, 60 degrees, and 90 degrees, across from the 30 degree angle, you're going to have a side length that we will call A. Across from the 60 degree angle, we're going to take that side length that's across 30 degrees, which was A, and we're going to multiply it by the square root of 3. Every time, no matter how big or how small, across from the 30 degree angle will be side length A, and then across from the 60 degree angle will be a bigger side length because it's a bigger angle, and its relationship is the smaller leg times the square root of 3. And then across from the right angle, we'll take that smaller leg A and multiply it by 2. And that relationship will happen every time with a 30, 60, 90 triangle. The other special right triangle is the 45, 45, 90. So it's 45 degrees, 45 degrees. Those are the two acute angles. And then the 90 degree angle is what makes it a right triangle. Now across from 45 degrees in either direction, you're going to have a leg, and that leg is going to be a length that we will call A. Because both angles are the same measure, the side lengths will also be the same measure. So we call that congruent. Congruent angles will have congruent side lengths that they are opposite of. And then across from the 90 degree angle, we'll take the leg, that leg length that we're calling A right now, and we multiply it by the square root of 2. The square root of 2. And that will happen every time. So let me do a few examples for you. We want to find the exact function value of all of these trig functions. So sine of 45 degrees, cosecant of 60 degrees, the tangent of 60 degrees, the cosine of 30 degrees, the cotangent of 45 degrees, and the secant of 30 degrees. First thing I'm going to do is I'm going to draw a right triangle. 45 degrees is going to be a special right triangle. It's 45, 45, 90. Now across from the 45s, I have a side length of A, and across from the 90 degree, I have A times the square root of 2. So this is something that you're going to want to remember. I'm going to resize this. Something you will definitely want to remember. Now the sine is opposite over hypotenuse. So I can choose either 45 degree angle, draw an arrow going to the opposite side, and then the hypotenuse will be always across from the 90 degree angle. And the sine of 45 degrees, the sine of 45 degrees, remember, is equal to a relationship. It's the opposite over the hypotenuse. And then we can simplify that. The a's cancel, leaving us with a 1 in the numerator over the square root of 2. And if we rationalize that by multiplying by the square root of 2 over the square root of 2, we get the square root of 2 times 1, which is the square root of 2, over 2. So the sine of 45 degrees is equal to the square root of 2 over 2. The cosecant of 60 degrees, I apologize for that, the cosecant of 60 degrees is going to deal with the 30, 60, 90 triangle. The 30, 60, 90 triangle, we're going to draw that, and I'm going to actually need to move some of this to another page because I want to give myself some room. So let me do that right here. I'm going to take this, I'm going to just cut it, and we'll paste it right there, and we'll come back to that. Oops. There we are. And now I'm going to give myself some room because I don't want you to miss out on anything here or get confused, because this right here is the basis, the foundation of our unit circle and where we're going to be going with trigonometry. These special right triangles are the premise of everything we're going to be doing hereafter. So the cosecant of 60 degrees. 60 degrees means I'm talking about a 30, 60, 90 triangle, because we're talking about right triangles. So the cosecant of 60, I'm going to draw my 30, 60, 90, and you can draw it however you want. Across from the smallest side, angle, is the smallest side, A. Across from the bigger acute angle is A times the square root of 3. And then across from the 90-degree angle is 2 times A. So that is something you're going to want to have memorized. It's a fact that you'll need to be able to recall. And then we're going to have the cosecant of 60 degrees. So when I write this, I write sine of theta, and then across from it is cosecant of theta. So the sine of theta is opposite over hypotenuse. Therefore, cosecant will be hypotenuse over opposite. So we're going to write that down. The cosecant of 60 degrees, because now our angle actually has a measure, is the opposite. So our opposite now is A times the square root of 3, and the hypotenuse is 2A. So it's going to be 2A, which is your hypotenuse, over the opposite side. Now the A's are going to cancel out. That's going to give us 2 over the square root of 3. We're going to rationalize that by multiplying the numerator and the denominator by the square root of 3. And we get 2 times the square root of 3 over 3. And that's the cosecant of 60 degrees. No variables. There's no variables in our fractional answer, because the A's are actually always going to cancel out, you will find. Let's try the tangent of 60 degrees. I'm going to redraw the picture because it's very helpful to continue to redraw, especially when you're just learning this. 30 degrees, 60 degrees. Remember, across from 30 degrees is A. Across from 60 is A times the square root of 3. And then across from the right angle is 2A. The tangent of 60, the tangent is opposite. So we're talking about 60 degrees again. Opposite over adjacent. So the tangent of 60 degrees is going to equal A times the square root of 3 over A. The A's cancel out, and the tangent of 60 degrees is equal to the square root of 3. Okay, now what I'm going to have you do is I'm going to have you try these 3, and we'll check your answers. So make sure you're pressing pause, and then come back when you're ready to check your answers. Okay, the cosine of 30 degrees. We're going to draw this out real quick. I've got 30 degrees, A, so I'm going to do this as quickly as you should be able to do this so that you can see how fast you should have this down. 30 degrees, opposite, adjacent, hypotenuse, adjacent over hypotenuse. The cosine of 30 degrees is equal to a times the square root of 3 over 2a. The a's cancel out, and the cosine of 30 degrees is equal to the square root of 3 over 2. If you got that, give yourself a pat on the back. Now we're cotangent of 45 degrees. So I've got 45, 45, 90. The legs are a, and the hypotenuse is a times the square root of 2. Cotangent of an angle is equal to not opposite over adjacent, but adjacent over opposite. So the cotangent of 45 degrees, the adjacent is a. I'm going to pick this 45, adjacent, opposite. So the adjacent is a, the opposite is a, and the cotangent of 45 degrees is equal to 1. Anything over itself is 1. Then we have the secant of 30 degrees. Secant goes with cosine, and cosine is adjacent over hypotenuse. So this will be hypotenuse over adjacent. I draw the 30, 60, 90. I'm going to circle the 30-degree angle. The opposite side is a. The adjacent side is a times the square root of 3. And the hypotenuse is 2a. So the secant of 30 degrees is going to be the hypotenuse, which is 2a, over the adjacent side. Let me label this. This is opposite, adjacent, hypotenuse. So the hypotenuse over the adjacent side. The adjacent side is a times the square root of 3. Hopefully you're seeing me do some things here with color. It's okay to show your work like that. The secant of 30 degrees is 2 over the square root of 3, but when we rationalize that, we get 2 times the square root of 3 over 3. So the secant of 30 degrees is equal to 2 times the square root of 3 over 3. And that introduces not only your special right triangles, but how we use them in trigonometry.